Okay, today I'm going to talk to you about hydrocarbons. We're going to have a look at what hydrocarbons are and how chain length affects their properties. So first of all, we're going to have a look at the definition of a hydrocarbon, which is this. A hydrocarbon is a compound containing hydrogen and carbon only. So this is why they're called hydrocarbons, because they contain hydrogen and carbon. The really important word to make sure you include in the definition is only. There are no other elements included in a hydrocarbon, only hydrogen and carbon. So we need to learn a little bit more about these now. So we're going to have a look at examples. Here's a hydrocarbon or two hydrocarbons that are kind of shorter in length, and here's two that are slightly longer in length. So to understand the properties of hydrocarbons, we need to understand a little bit more about the bonds within them, because there's two different types of bonds going on that we need to be aware of. Now, within a hydrocarbon itself, we have forces called intramolecular forces. These are strong covalent bonds within the molecule itself. So it means within the molecule. The other type of force we need to know are intermolecular forces. Now, intermolecular forces means between different hydrocarbons. So if I was to just draw them on, just here, it shows attractions that are between two different molecules. Now, the way that I remember this is by thinking about intranet and internet. If you have an intranet, for example, in a school, it connects all the computers within the school itself. The internet obviously connects us with loads of other places as well. So that's the way I personally remember the difference between intra and intermolecular forces. So I'm just going to draw the intermolecular forces, or just a diagram to show these intermolecular forces acting on the longer chain one, because that will help us understand a few things. Because what we need to do is we need to understand how chain length affects different properties. To begin with, boiling point. So when we boil one of these hydrocarbons, we're obviously changing state from a liquid to a gas. In order to do that, we need to break these intermolecular forces, the forces holding the different molecules together. We are not breaking these strong intramolecular forces. So as this evaporates, we still have this three-chain hydrocarbon here, which is actually propane, but we have broken these intermolecular forces, so they are no longer being held together or attracted towards each other using these intermolecular forces. As a result, the shorter the chain, the lower the boiling point. Now, this is because less force is required to break these intermolecular forces compared to if we have a longer chain, we could have attraction all the way along the chain length. So more energy would be required in order to boil the longer chain ones. So that's how chain length affects boiling points. Next up, we need to know about this thing called viscosity. What viscosity means is how runny or how thick a substance is. So the shorter the chain length, the lower the viscosity, i.e. it will be much runnier. Now, the reason for that is essentially if you have longer hydrocarbons, there's basically more forces holding it together, so it will be more viscous, it will be more thick. So these kind of thick consistency is described as having a high viscosity. So thicker, a little bit like treacle or syrup, so much thicker. The final thing we need to know about is about how easy it is to ignite. The shorter the chain, the easier it is to ignite. Now, the reason for this is shorter hydrocarbons tend to be gases at room temperature. So these gases can mix with oxygen in the air, which bursts into flames nice and easy. The longer the chain, the higher the boiling point, so it's less likely to be gaseous, it's more likely to be a liquid, meaning it's less easy to ignite. So the longer the chain, the more difficult it is to ignite. Ignite just means to set it on fire, for it to catch fire. So, this is basically the features of hydrocarbons and how chain length affects these different properties. Thank you.